Is Java pass by value or pass by reference? Everyone seems confident until they hit a weird bug. Today, I'll break it down once and for all using stack and heap memory, and I'll prove to you why Java isn't what you think it is. Here's a simple Java program. What do you think this will print? You've got 10 seconds to figure it out. Need more time? Pause the video, jot down your answer, and then hit play to see if you got it right. Your 10 seconds start now. Time's up. Let's break this code down. We start by defining a simple person class with a name field, a constructor to initialize the object, and a toString method that returns the name. Next, we create a tester class. In the main method, we create a person object named John. We then pass this person to a method called checkPerson. Inside the checkPerson method, we check if the parameter p is null. If it is, we create a new person named Mary. Otherwise, we set p to null. After the method call, we print p, then explicitly set p to null, and call checkPerson again. Alright, now let's run the code and see what actually gets printed in the console. It prints John, then it prints null. Why? You called a method that creates a new person, but it seems like nothing happened. Is Java broken? Nope, it's you. Or rather, it's how Java works under the hood. And today, we're going to decode it completely, from the stack, to the heap, to what you thought you knew about method parameters. Now let's talk about how memory works in Java. Java has two important memory areas, the stack and the heap. In Java, the heap is where actual objects live, like anything created with new. For example, objects, like our new person John, live in the heap. It's shared across all threads and managed by the garbage collector. The stack, on the other hand, stores method calls, local variables, and references to heap objects, but not the objects themselves. Each thread has its own stack. When we write person p equals new person John, the person object is created in the heap, and p is a reference on the stack pointing to it. Now let's walk through the execution step by step and see exactly what's happening behind the scenes. Step 1. Person p equals new person John. This line creates a new person object in the heap with the name set to John. The reference variable p, which lives on the stack, now points to that object in memory. Step 2. We call the checkPerson method and pass the reference variable p. Here's the trap. When we pass p into checkPerson method, we are not passing the object itself. We are passing a copy of the reference. That means checkPerson method gets its own reference to the same object, but any reassignment to that reference doesn't affect the original one. P is not null, so we go into the else branch. So when we do p equals null inside checkPerson method, we're only changing the local copy of the reference, not the original. This local reference is stored on the stack, and setting it to null doesn't affect the original p in main method. The object in the heap remains unchanged, and main method still holds the original reference. Step 3. The variable p in main method still points to the original person object with the name John, so this line prints John. Step 4. Now we explicitly set the original reference p in the main method to null. At this point, p no longer points to any object in the heap. Step 5. Now p is null. We pass null into the checkPerson method. Inside the method, it checks if p is null. Since p equals null, it enters the if block and creates a new person Mary, assigning it to the local variable p. A new person Mary is created in the heap. Local p inside the method points to it. But again, the original p in main is not updated. So this line also has no effect outside checkPerson. Step 6. The The variable p in the main method is still null, so this line prints null. This isn't a bug. It's how Java is designed. Java treats everything as pass-by value. If you pass a primitive, it copies the value. If you pass an object, it copies the reference. Want to modify the object? Sure. But want to change what the reference points to? Not going to work. This is also why John becomes garbage collected later. We null the reference in main method, so no one is pointing to it anymore. Quick recap. Java is pass-by value. Always. When you pass an object, you're passing a copy of the reference. Changing the reference? Local only. Changing the object? That works. And everything sits in stack or heap. Now, the next time your object disappears, you know exactly what happened and why. Got it. Great. Let's finish strong. This question is to check if you stayed with the video till the end. So tell me, what happened to John in the end? Drop your answer in the comments. Like the video if you learned something. Subscribe for deep Java explanations. Share it with a friend who's always confused by stack and heap.